All right, so get this. We're going to dive into something kind of crazy today.
Oh.
The possibility that our ancient ancestors, way, way back, might have actually hibernated. Like, seriously.
Right. Hold on.
I know, right? Sounds like sci-fi. But
It does.
we're talking 430,000 years ago.
Wow.
Those amazing fossils from Atapuerca, Spain. You know the ones?
Yeah, I've heard of those.
Well, some scientists think the weird bone stuff they're finding, like lesions, it could be signs of hibernation.
Really? That's wild.
Isn't that nuts?
Totally changes how we think about early humans, if that's true.
Right. So we got to explore this, how hibernation even works.
For sure.
And get this, maybe even how we could use it today, like medicine, even space travel.
Now that's getting me excited. Those are some big implications.
Big time. So let's start with those Atapuerca fossils. What makes them so special? Why do scientists think they're pointing to hibernation?
Well, the Atapuerca site, it's super old. It gives us a look into a period we don't know much about, human evolution, the really early days. And the condition of these fossils, that's what's got everyone buzzing. They've got damage patterns, like really specific ones, lesions, weird bone growth, and it's similar to what we see in animals that hibernate.
So we see those same weird bone things in animals today. Does that mean, bam, our ancestors were napping all winter too?
Not so fast, gotta be careful. Just because things look alike doesn't mean they are alike.
Good point.
Could be other reasons for those bones,
Great.
But then think about what those early humans were dealing with, the environment, and hibernation starts to make more sense.
Okay, paint me a picture. What was the climate like back then? Rough.
Imagine Europe, but 430,000 years ago, brutal winters, long and harsh, food was scarce too.
Thanks.
And these early humans weren't exactly built for that. Not like us, we're tropical folks at heart.
Yeah, good point.
They were venturing into tough territory.
So they're facing this crazy climate. How does hibernation help? Like slowing your body down, how does that equal survival?
That's where hibernation gets brilliant. It's all about saving energy.
Oh, I see.
No food, freezing temps, hibernation kicks in, slows the metabolism way down.
Like a power saving mode.
Exactly. We call it hypometabolism, lets them survive on almost nothing until things get better.
Hypometabolism, so it's more than just sleep. It's like turning down every dial in their body.
You got it. Heart rate plummets, breathing slows, temperature drops, the whole 9 yards.
Wow.
Some animals, their metabolic rate goes down to 2% of normal.
2%. That's insane. Okay, what's going on in their brains, though? What's the switch that flips for hibernation?
Still figuring that out completely, but we know the hypothalamus is key, and the brainstem, too.
Oh, yeah, those are important parts of the brain.
They control all the vital stuff, temperature, sleep, hormones. And during hibernation, special brain chemicals, neurotransmitters, they increase.
Like what?
Adenosine. For one, it's like telling the body, time to chill, conserve energy.
Fascinating. So it's not just about being cold, it's this whole brain chemistry thing going on, too.
Exactly, the body and brain working together.
So are there other primates that hibernate? Maybe that could give us more clues about our own ancestors.
Good question. And yep, some primates hibernate, or well, torpor is more accurate.
Torpor? What that?
It's like a lighter version of hibernation.
Okay.
Think lemurs, bush babies, they don't sleep all winter like bears, but they slow down when times are tough.
Interesting.
Shows us that maybe this ability is more common in primates than we used to think.
Huh. So we got these weird bones, some primates do it, and we're starting to understand the science, but how does this connect to US today? Could we hibernate? And why would we even want to?
Now, those are the million-dollar questions, and that's what we're going to dig into next. Human hibernation today could be huge for medicine, even space travel, like, imagine that.
I'm hooked. Let's get into it.
Okay, so picture this.
I'm listening.
Astronauts sleeping their way to Mars.
Whoa, okay, that got my attention. How's that even work?
Induced hibernation, or torpor it's called, could be the key to long space missions, like way long.
I mean, that sounds straight out of a movie. How realistic is this? And why would sleeping astronauts be better than, well, awake ones?
Might sound like sci-fi, but it's not. Agencies like the European Space Agency, they're looking into it. Seriously.
Really? Wow.
Think about it. Sending people to Mars, it's a huge challenge. The distance, the time, all the supplies you need.
Yeah, not to mention what it does to your body being in space that long.
Exactly. The health risks, the mental strain, it's a lot. But if they could just sleep through most of it.
Okay, yeah, that changes things.
Smaller ships, less stuff to bring, maybe even less radiation exposure.
So what, they just like climb into these space pods and snooze?
Not quite that simple, but the idea's there.
Okay.
You got to create this super controlled environment, right? Temperature, vital signs, making sure they get nutrients.
So it's more than just putting them to sleep. It's like a whole life support system built for torpor.
You got it.
What about when they wake up? Would their bodies be like messed up after all that time? Muscles and bones and all that?
Oh, for sure. Those are things scientists are working on, figuring out how to prevent that.
Okay, good.
You could use stuff like electrical stimulation, special exercises, got to keep those muscles and bones strong.
Interesting.
And then waking up on Mars, that's a whole other thing, the psychological impact. Got to think about that too.
So lots of challenges still.
Definitely, but progress is being made all the time.
Like what kind of research is happening right now?
Well, they're looking at different ways to induce torpor safely, learning from animals that hibernate, and also from therapeutic hypothermia.
Oh yeah, that's where they cool down patients after, like a heart attack, right?
Exactly. It's already being used in medicine.
Huh. So it's kind of similar.
In a way, yeah. Therapeutic hypothermia, it's only mild cooling, short term, but it's a starting point.
Makes sense.
Scientists are figuring out how to go deeper, longer, using drugs, cooling techniques, even studying specific brain chemicals.
Wow, so we might actually be able to harness this ancient thing, hibernation, for modern problems.
That's the idea. And it's not just space travel. Think about medicine. The possibilities are huge.
Okay, like what? Give me some examples.
Imagine someone's badly injured, you put them in torpor, gives doctors time to fix them, no rush.
Oh, I see. Buy them some time.
Right, or organ transplants, keep those organs healthy longer.
That's incredible.
And remember, we talked about cell damage and aging. Hibernation could protect against that. So many diseases could be a game changer.
That all sounds amazing, but what about the ethics of it all? Messing with something like hibernation, is that even right?
That's the big question, isn't it? We got to be super careful here. Lots to consider. Can't just jump into it.
Yeah, I hear that.
We need rules, guidelines, got to make sure it's used for good, not for bad, you know.
Okay, so we've covered a lot of ground here, the evidence that our ancestors might have hibernated, how it actually works, all that science stuff.
Right.
And we even got into how we could use it today. Space travel, medicine, the possibilities are, well, pretty mind-blowing.
For sure.
But like with anything powerful, we got to think about the downsides, right?
Yeah, absolutely. Can't just ignore the ethical and practical stuff that's super important with something like this human hibernation.
So what are some of the big ethical worries people have? What are the experts saying?
Well, one of the biggest things is misuse. You know, could this technology be used to control people, exploit them?
Oh, yeah, I see what you mean.
We need safeguards, got to prevent that kind of stuff from happening.
Makes sense.
And then there's the whole issue of access. Like, if this becomes a real thing, will everyone be able to use it?
Right, or will it just be for the rich and powerful?
Exactly. We got to make sure it's fair, socially responsible, all that good stuff.
Okay, so ethics is one thing, but what about the practical challenges? Like, how do we even keep people safe and healthy in torpor for a long time?
That's the million-dollar question, right? How do we deal with muscle wasting, bone loss, the mental side of things? There's a lot to figure out.
It sounds like we're still a ways off from seeing this in everyday life.
Yeah, but the research is moving fast, and it's exciting stuff, you know? It really shows us how much we still don't know about our own bodies.
True. And it pushes the boundaries of what we thought was possible. I mean, human hibernation, that's wild.
Totally changes how we think about human potential. And it could open up so many doors. Who knows what we'll find out next?
It's pretty humbling and kind of scary, too, all at the same time.
For sure. It makes you think, right? About our place in the world, where we're headed as a species.
Well, on that note, I think we've given everyone a lot to chew on today.
Definitely.
Thanks for joining us on this deep dive into human hibernation. It's been a wild ride.
It's been a pleasure. Always happy to talk about this stuff.
And to our listeners, keep those brains buzzing, keep asking questions, and who knows, maybe one day we'll all be taking a little hibernation vacation.
Now that's a thought, haha.
Until next time, everyone, take care.